Hey guys, welcome back to geometry. Today we're going to take a look at finding the distance either from a point to a line or the distance between two parallel lines. Now, we all know the old adage, the shortest distance between 2 points is a straight line. Oop, not a straight line. Okay, now what if instead of just going the distance between 2 points, we want the distance between a point and a line? So let's think about this, guys. First off, whenever they ask you for the distance, what they really mean is the shortest distance. Okay. Of course, there's a lot of different ways that we could say the distance. We could say from this point P to this point up here, which is on line M, or this point P to this point here, which is on line M. But really what we want is the most direct or the shortest distance. So let's take a look. Okay, if I put a line starting at P, okay, and I slide along this line M. Okay, this line is getting shorter and shorter and shorter, and then right around here it starts to get longer and longer and longer. So come back to where we think it's right about the shortest. Okay, now what do you think is what do you think is going on here? Why is this line the shortest? Well, if you stop and think about it for just a second, you'll realize that this is the segment that is perpendicular to that line. Okay, so the shortest distance between a line and a point not on that line is the length of this segment. Okay, so the length of a segment perpendicular to the line containing the point. Okay, so what we need, guys, is the length of this segment right here. Okay, from P to this line, and we'll tell you what, we'll call this point P prime. Now, one thing that's really important to note, right now, this point P prime happens to be the y-intercept of this blue line M. That will not always be the case. That's a coincidence this time, okay? Let's think about this. How would I find the length of this segment? Well, if I'm talking about a length on the coordinate plane, I'm probably going to want to use the distance formula, okay? Because that's the crux of it all. Is right down here. Let me get this the right size so we can see everything. There we go. Okay, right here. Okay, we say we're going to use the distance formula to find the length of this segment. Okay, well, if I'm going to find the length of this segment, I have the coordinates for P. I need the coordinates for P prime. Okay, so I need to find that endpoint. Now, how can we do that? Well, I want to find where this segment intersects this line. So what I need to do is solve a system of equations for this line and this, for this segment and this line that we were originally given. So I'm going to have to solve that system. But before I can do that, I need to find the equation for that line. Now we know that perpendicular lines have opposite reciprocal slopes, and we have a point that's on this line. So all we really need to do, it's going to take a little bit of time to do this process, but nothing on here is new at all. Everything is stuff that we've done before. Okay, find a perpendicular slope, find the equation of this line, and find the point where those two lines intersect. Okay, so let's work through an example here where we do exactly that. Oh, that's not it. There we go. Okay, we want to find the distance from line K described by y equals the opposite of x to Q, which is 1, 5. Okay, well, first off, the slope of this line is -1. So the slope of a line perpendicular to that would be the opposite reciprocal. So it would be +1. Okay, this reciprocal of 1 is still 1 over 1, so still just 1. So the equation of the line containing a slope of 1 and x1, y1 of 1, 5 would be y minus 5 equals 1 times the quantity x minus 1. Okay, and to make this equation a little bit easier to work with, we'll distribute that 1, so we'll have y minus 5. 1 times x is just x, minus 1 times 1 is 1. We'll add that 5 to both sides, and we'll say y equals x plus 4. Okay, now, I'm well aware someone is going to say the distance between these 2 points, we can stop right here, is going to be 4. Because this one is just y equals the opposite of x, and this one is y equals x plus 4. Well, guys, remember, those equations are not necessarily all there is to it, okay? If I were to graph those lines, just a real quick sketch on this coordinate plane here. Here's y equals the opposite of x, okay? And here is y equals x plus 4. Okay, yes, the distance from here to here is 4 units. But remember, we want the shortest distance, which is going to be this perpendicular line. So there's going to be a little bit more to it than just saying 4. Okay, we are going to have to go through the rest of the process. We're going to have to find the equation of this line, which we did. We're going to have to find the intersection of this line, and then we can use those to find the distance. Okay, we'll take a look, guys. I have y equals the opposite of x, and y equals x plus 4. So I can take those two equations and set them equal to each other. The opposite of x equals x plus 4. Okay, solve these equations for x, so I'll subtract x from both sides and get minus 2x equals 4. Divide both sides by negative 2 and get x equals negative 2. Now, once I have a value for x, I can take it and I can sub it all the way back into one of those original equations. Doesn't matter which one, so I'll sub it into this one, okay, and get a value for x. Okay, so I can say y equals the opposite of negative 2. Okay, so that'll be y equals positive 2. So this q prime that we need to define is the ordered pair negative 2, positive 2. Okay, now the last thing that we need to do is find the distance from q prime to q. So let's say q prime is equal to, now let's go down here where we'll have a little bit more space. Big old square root of, let's call this one x1, y1, and this one x2, y2. Okay, so x2 is negative 2 minus your x1 is 1, quantity squared, plus your y2 is 2 minus your y1 is 5, quantity squared. Okay, now negative 2 minus 1 is going to be negative 3. Quantity squared is going to be 9. Plus 2 minus 5 is also negative 3. Squared is also 9. Okay, so this equals the square root of 18, which we can simplify to 3 times the square root of 2. Okay, and there we go. Okay, let's take a look at another example. Okay, so I want to find the distance from line J described by this equation to this point P. Okay, well, first thing that I want to do, I need to find the equation of this segment from P to P prime. So the slope of this equation that I have right in front of me is 4/3. The slope that I'm going to use with this line, call it M prime, is going to be negative 3/4. Okay, so I have a slope, I have an x1, y1. Let's sub those in and say y minus negative 2 equals negative 3/4 times the quantity x minus negative 7. Now I'll clean this up just a little bit, and I'll say y plus 2 equals negative 3/4 times the quantity x plus 7. Okay, and here we go, guys. We've got an equation, the function for the line including P and P prime. Now, I got to find P prime. The way that I'm going to do that is I'm going to solve a system of equations for this equation and this given equation. Now, we solved systems before. We know that there are tricks, things that you can do. Here's what I want to try here, okay? I want to get this y all by itself. And I'll show you why in just a minute. So I'm going to make this equation in point-slope form, slope-intercept form. So I'll distribute that negative 3/4, and I'll have y plus 2 equals negative 3/4 x plus negative 21/4. Okay, and then I'll subtract 2 from both sides. Okay, now if I want to subtract 2, I'll need a common denominator. So let's make that 8/4. Okay, and I'll have y equals negative 3/4 x plus negative or minus 29/4. Now, we look at this equation, we look at both of these equations, and we see some fractions, and that makes us a little bit nervous. Okay, but here's the deal, guys. Fractions are just numbers. They're not really going to change what we do for our approach big picture. We may have to do a little bit more scratch work along the way, but they're not really going to affect how we solve these problems. Okay, now let's look at this. I have a system of equations where I have y equals 4/3 x minus 1 and y equals negative 3/4 x minus 29/4. There are a couple of different ways that I can solve this system. What I'm going to do is solve using substitution. Okay, these are both equal to y, so I'm going to set the other halves of these equations equal to each other. So we've got 4/3 x minus 1 equals negative 3/4 x minus 29/4. Okay, and now we'll go ahead and solve. So I'll add 3/4 x to both sides, and over here get that common denominator. That's going to end up being, well, let's do some scratch work. Okay, this 4/3, I'm going to multiply that top and bottom by 4 and get 16/12. And then 3/4, I'm going to multiply top and bottom by 3 and get 9/12. So I've got 16/12 plus 9/12 is going to give me 25/12. X minus 1 equals negative 29/4. Okay, then we'll add this 1 to both sides. And I'm actually going to put this back over here. Okay, so if I add 1 to both sides, I've got 25/12 x equals, okay, add 1, so that'll be 4/4, so that'll be negative 25/4. Okay, now, I want to get that x all the way by itself, so I'm going to multiply by the reciprocal, 12/25. Okay, on both sides. Okay, on the left side, easy, those cancel. X is all by itself. On the right side, if I do these negative 25s are going to cancel, and I'll have negative 12/4, which is just negative 3. All right, now we've got x, we need to use x to find y. So I'll take that x equals negative 3, and I can sub it into either one of these two equations. Tell you what, I'm going to sub it into this one. The reason I'm going to pick this one is because if I put this negative 3 in place of x, those 3's are going to cancel, and I'll be dealing with integers. Okay, so let's say y equals, sorry about that. Let's say y equals 4/3 times negative 3 minus 1. Well, 4/3 times negative 3, those 3's are going to cancel, and we'll get y equals negative 4 minus 1, which means y equals negative 5. So, this was a lot of work to find p prime, which is the ordered pair 3, negative 3, negative 5. Okay, now, we're almost there. We're going to use this point to find the distance from p to p prime. So from negative 3, negative 5 to negative 7, negative 2. All right, we're almost there. We'll take those points, we'll sub them into our distance formula, and we'll have that distance is equal to x2 minus x1, so let's say negative 3 minus negative 7. quantity squared, plus our y2 is -5 minus our y1 is -2. Double check on that. Yep. All right. Okay, now we'll have minus negative is plus plus, so -3 plus 7 is going to be 4 squared. Minus negative is plus plus, so -3, or -5 plus 2 is -3 squared. So 4 squared is 16, 3 squared is 9, 25, which is equal to 5. Whew, so yeah, that takes a little bit of while to do. Okay, but here's the deal, guys. Nothing about this is new. Okay, this is all stuff that we've been doing. Okay, we find the equation of a perpendicular line. We solve a system of equations. We find that point, and we find the distance from this point to that original given point.